Hey, look, it works now. All right, hello.
Hello.
All right, better. Okay, so yes, guest teacher today is Mr. Silva, and it's not lined up. There we go. Now it's lined up. All right, so we left off here yesterday with something. This problem right here. So we're doing analyzing monthly sales. So what we've been talking about is trying to minimizing, maximizing, and finding concavity. So unit monthly sales are of new product over a period of time are expected to follow the logistic function, okay, where t is going to be greater than 1 or greater than 0. So can't have any negative times here. Where t is measured in months. Where are the monthly sales increasing? When are they decreasing? Find the rates of change of sales. When are the rates of change sales are prime increasing? When are they decreasing? So, mins and maxes, all the good stuff. So, let's go ahead and start off with my function. So, I need someone to read this off for me so I don't screw it up. What do we got?
20,000 over 1 plus 50 e.
50?
Yeah.
E to the?
Negative t. Minus 2,000 over 51. I mean, 20,000.
20,000?
Yeah.
Over?
51.
Like that?
Yeah. And t is greater than or equal
Okay,
to
t is going to be greater than equal to 0, so that means there's no negative time. I thought I changed this already. There we go. Okay, and so this is my r function. So r prime. So I'm going to go through and do a derivative of this. We could either do chain or we could do quotient. I think I'd rather do quotient though. So the reason why I'd rather do quotient is because this 2,000 or 20,000 right here is going to go away nice and pretty. So we're going to do each part individually, but when I take the derivative of this, that all goes away, right? Okay, so I'm going to have r prime is equal to, so if this is f and this is g, so f prime would be 0 times my 1 plus 50 e to the negative t, all right, and minus 20,000. Is that enough zeros? Yeah. Okay, now times the derivative. Okay, times, okay, the derivative of this. So the derivative of that is going to give me what?
negative 50t.
Negative 50 e to the negative t, right? So because the t right here, that's just a 1. So the derivative would be a negative 1. So I get negative 50 e to the negative t. Right there. All that's going to be over 1 plus 50 e to the negative t squared. There we go. Okay, so now anything times 0 gives me 0, so that first thing is going to be nice and pretty. It goes away. The two negatives make a
Positive.
So I'm going to have a positive right there. So it is a positive 20,000 times 50 is 20,000 times 5 is 100,000. 1 million. Yeah, there we go.
E to the negative t, right?
Yeah, so 1 million there. Okay, and that's going to be e to the negative t all over. So this is going to be a 1 plus 50 e to the negative t squared. This is my r prime. Okay, so now we're talking about critical values. So my first derivative, critical values. What should I check for right now? Not 0 yet. Asymptotes or
Pole.
holes, undefined, right?
Oh,
where's my derivative going to be undefined? So where's my derivative going to be undefined? So where is the bottom going to be equal to 0, right? So because how this function is, it's going to look like this. So I'm going to pull this aside. 1 plus 50 e to the negative t, right? Even though it's squared, that's not going to matter, right? That's not going to matter, even though it's squared. So set that equal to 0. And we're trying to solve for t here. So let's move this over. So it's a negative 1 equals 50 e to the negative t divided by 50. So it's negative 1 over 50 equals e to the negative t, right? Okay, so what can I do with that negative exponent? I can ln. I can, but I don't want to do that yet. I don't want to do that yet. I want to take care of it now.
Just put it over.
1 over, right? So it would be 1 over. So I have 1 over, negative 1 over 50 is equal to 1 over e to the positive t. So now e to the positive t is going to help me out because that's, okay, easier to deal with than that negative t. All right, multiply both sides by e to the t, right? And then divide. So I should get a little bit of mental math here. It should be e to the t equals, yeah. Now, looking at this and knowing your e's and ln rules, is e to the t ever going to be negative 50?
No.
It's not. It's not. So it's not going to work out because when I do this, it would be an ln both sides, so it would be t equals ln of negative 50. Go ahead, see what your calculator says.
Oh gosh, non-row calculations.
There we go.
So that's the software, is the real setting.
So they do not like it, do they? They do not like it here or there. So that's important. If that was a positive, would that have worked? Yes. If that was a positive, that would have worked. So we have to check for those, okay? So that's a place that it would have been undefined if it was a positive. But in this case right here, it's not. It's not. So am I going to have any place where my derivative is undefined? No. I don't have any place where my derivative is undefined. So let's go ahead and I'm going to back this up. So I'm going to erase a little bit here. Okay, so now we don't have any place where my derivative is undefined. So let's check to see where my derivative is equal to 0. And that's going to give me my mins and maxes. Set this equals 0. This is my favorite part. Why is it my favorite part?
Because you don't have to worry about it.
I don't have to worry about the bottom, right? Multiply by the common denominator, my denominator goes away because anything times 0 is 0. So I got rid of my whole denominator there. My whole denominator. Now I'm left with this. Divide by 1 million. What do you get? Okay. So it's going to be 0 equals e to the negative t, right? All right. So what would I do from here? do I do from there? What did we do last time?
1 over e to the t.
Uh,
ln.
that's not gonna work out on this one, because if when I multiply it out, I have a 0 over here, so that's not gonna work out for me. So I can ln now. So if I ln now, it's gonna be ln both sides. So ln 0 equals negative t. Now what is ln 0? Undefined. So this one right here is going to be undefined. Okay, and we also came up with another one. So let's pull up the graph on this one, because this one's going to be important. Excuse me, my dude. Pull my calculator software. Ah, dang it. There you go. So if I did my math correctly, and this gives me undefined, what does that mean? I'm not going to have any places that are going to be equal to 0, right? So critical points. So let's go ahead and check to make sure. There we go. All right, so pull up the calculator and control divide 20,000 over 1 plus 50 e to the negative x, right? Then it's minus 20,000 to 1, 2, 3, 4 over 5, 1. Ooh, 5, 1. There we go. All right. Dang. So what is that telling me? What does it tell me about my values? So what does it tell me about my values? What do I have to change here to see my values? Yeah, let's change the window. Okay, so now t values are just going to be greater than 0. So let's go through, and so that means my x is, not that one, that one. Okay, and window, settings, start with 0 for my t values. And let's go to 50. See if that works. And I know my y min should be what?
0.
0. Very good. It's a graph of revenue, isn't it? It's a graph of some revenue. I don't want to see anything below, below 0, right? I want to know mins and maxes. So I don't want to do that. So now, what about this? What do you think y max should be? Let's start with 20,000. The reason why we started with 20,000 because that's one of the values in my function that I was talking about. So 20,000 divided by something. Let's go 25. Is that 25,000? Yeah. Hit OK. I said hit OK. There we go. All right. Hey now. Look at that. So, again, neat curve there. Got a neat curve there, though. All right. Okay, so what is it telling me at a certain point as x gets bigger? Yeah, it stops increasing there, right? So it stops increasing, but it might just increase. Yeah, at a very tiny rate. That's the reason why I might have got no zeros on that. So let's see. So we're trying to find certain values, right? Let's try and find the max. Let's see what the calculator says. Menu, analyze graph, and we want to find a maximum. So let's pull it over here, and if you notice, look what's happening here.
It's not increasing. Oh, never mind.
Looks like it's increasing, but it could still be increasing, but I just can't see it anymore, right? So at a certain value, it looks like it should stop at 33. But if you notice, even though our graph shows this, okay, so let's now change this because we're saying that my y value is about, let's say 19,000 to 20,000. Let's see if I could actually see any change in that one. So menu, window, settings. So we're doing 19,000 now. And then let's go 20,000. There we go. Dang, you know what? That's a pretty flat line, isn't it? Okay, so it's still going to give me that. So according to this, it looks like my value is going to come out to be at 33. Now, what does this right here on my calculator say? 1.96 e to the positive 4. What's that mean?
Times 10.
Yes, scientific notation. So it's a scientific notation, but your calculator just says e instead of the times 10 to the negative 4 or times 10 to the positive 4. It says e, so it abbreviates that as an e. So it means that there is 4 digits for the decimal on that one. So that's where I came up with my 19,000. So it looks like it levels off, doesn't it? Okay, let's go back to my questions then. So it looks like because of the way this was, okay, when are the sales increasing? So this is the function, right? Function, and I want a positive slope. So positive slope look like it happens when? In between, looks like right about here, right? And like levels off at some point right in here. Some point right in here it's going to level off. So, I don't know, let's check to see what my graph says. So menu, let's trace graph. Let's see, what is it right here? Ah, dang it. Stop it. Don't, get out. Why did it do that? Menu, trace, graph. Okay, I'll do it like this instead. So if I look at my values, so right about here, we're at about 12.5, or, there we go. Right about 13, it looks like it's getting to the point where it just flattens out. So if you notice, it's slightly going up now. Barely going up, but it's 19,607, right? Keeps going, keep going. So it looks like it should be maxing out about 19,607. Okay, the decimals keep going, right? But it's still, as I keep going. So there is no actual maximum, but if this is a business here, and you're running this business, yes, you are increasing, but you want to increase the most, right? So the most increase that you would get is going to be between whatever this is here and, or basically my start to 13. 13 looks like it's going to be what I was looking for. So right about 13. Now, playing with your calculator is probably the best way that you could actually figure out how to do a lot of this. The calculator just did most of it for us, even though mathematically, numerically, we're struggling because it didn't have any place where my derivative is equal to 0. It also doesn't have any place where my derivative is undefined. So by critical points, I don't have any critical points, do I? I don't have any critical points, so the graph is going to help me from this. So if I didn't have any critical points there, I might have a critical point where I have second derivative, but does it look like it's changing concavity?
No.
It actually is.
Really?
Yeah. So let me go menu, let me change my window back to my 0 here. Nope, there we go. Okay. So if you notice this part right here, as I start at 0, this, do the hand sign, gang signs right here, that's going to be a concave up, right? So somewhere in here, it's going to change concavity. So from my graph, I can see, oh, hey, look, that is concave down now. So I have a second derivative in between 0 and 13.
Yeah, but it's not going, but the top end isn't going down though. It's still like 8.
It is, but it's now like this, isn't it? It's like this, isn't it? Yeah, it is, isn't it? So if down here it's like this, that means at some point there's a point that it changed concavity.
Yeah.
So in between these two, there is a second derivative equal to 0 or
Is undefined.
undefined. Thank you. Or is undefined. Okay, so let's see what the math says. Okay, inflection points of R. So let's carry over my derivative to a new one. So R prime was 1 million, right?
Yeah.
Over
Yeah, it's 1 million e to the negative 2.
E negative t, right?
Yeah.
And
1 plus 50 e to the negative t squared.
you okay? Yeah. All right, so take a derivative. You don't want to take a derivative?
No.
No. Why?
Okay.
It's going to be a product in a chain, right? Just big numbers.
Ugly though.
Okay. So let's take a look. Right here, if I do this, it's going to be the quotient rule, right? Quotient rule again, so derivative is going to be a negative 1 million. 1 plus 50 e to the negative t squared minus, and the derivative of this is going to be 2 quantity of 1 plus 50 e to the negative t, right? And to the first times the derivative of the inside, which is negative 50 e to the negative t, times 1 million and e to the negative t. Ah, there we go. Crammed it in there. That's enough zeros. All right, all that's going to be over 1 plus 50 e to the negative t squared to the fourth, right? Squared squared. Squared squared gives me fourth. So I should have some place where my derivative is going to be equal to 0, right? Yeah?
Yeah.
Okay, so it's going to be my R double prime So let's take our calculator and I'm going to do this. Let's new tab, and I want a derivative equal to 0, right?
Yes.
A derivative equals 0, or I could also say that I'm doing what? A min or max of the derivative. So do I need to plug in the second derivative?
No.
If I do, I look for what? 0, right? But if I plug in my first derivative, I can find min and max. So let's go ahead and do that. So it's going to be my first derivative. So control divide was, come on now. Okay, it doesn't matter what number it is. All right. So control divide 1 million, right? E to the negative t, all right? Over parentheses 1 plus 50 e negative t close squared. There it is. So mathematically, that problem sucked. Okay? But graphically, now can I see what I needed? There it is right there. So this one's actually pretty easy now to see where it's at. So since I know I have a change in concavity, so my derivative, my min and max of my derivative, so there's my change in concavity. So let's go ahead and figure that out. Menu. Okay, analyze graph, and we want a maximum. So my maximum is going to be this graph. Lower bound is right here. Upper bound is right there. So it's about 3.91. So please, please, please take time, play with your calculator. Okay. I highly recommend you guys coming in, advisory or after school, use this calculator. If you checked out one of the 84s from me, those ones also do the same thing, but the buttons and how you actually input it is different. So you could actually find a YouTube or like a how-to online if you guys are using the 84s. All right. Okay. So don't forget, like, share, and subscribe. Hit that notification button and try not to fall asleep in the front row.